Hi and welcome. My name is Markus Koschany and I'm a Debian developer and also a Java team member. Today I want to give you some insights into the Java in Debian and what challenges we face during our daily packaging work. Java is a very important language in Debian. If you just count source code lines, it ranks in third place, only after C and C++, which are used in 2/3 of our software packages. With more than 19 million source lines of code, there's slightly more Java code in Debian than Python. I know what some Pythonians will say, it's because of the boilerplate, and they are probably right. But still, it is a very important language. And it has a significant number of source code lines, 3 times more than Perl. And Perl is a very significant language in Debian because almost all our most important system tools are written in it. The Java team alone maintains about 1,000 source packages, or another count over 1,600 binary packages. This is almost 11% more than we had in Debian Stretch. Of course, we are not the only team which deals with Java. There are other teams like Debian Met or Debian Science who deal with specific software packages or software written in Java. For example, for scientific research, bioinformatics, or medical care. Here we have also a dedicated team for Closure, and there's another team for packaging Android software. So if you ever wondered how you can build the Android operating system from source, there's a dedicated Debian team who does only that. According to our popularity contest, which is opt-in, more than 40% of all systems report that they have an OpenJDK 8 installed on them. So you can see there's a lot of demand for Java. Popular applications that use Java are LibreOffice in parts, NetBeans, Sweet Home 3D, FreePlane or FreeCall. We expect similar numbers in our upcoming Debian 10 Buster release. What can you expect in Debian 10 Buster? So first of all, very important, we have completed the OpenJDK 11 transition, which required more than 400 package updates. Actually, I wanted to complain a lot about the grief that was caused by the transitions, but someone told me to keep the talk positive, and I shall not rant, so I skip that part for now. Let's move on to build tools. Ant and Maven are up to date. We have some problems with Gradle. It is stuck at the last pre-Kotlin version because the Gradle developers decided to rewrite some of their build scripts from Java to Kotlin. That sounds like a simple problem, but for us it means we have to package Kotlin to build Gradle from source. And this is quite hard because Kotlin build depends on itself, so we have to bootstrap it, and this is, a hard task. But help is wanted, and we want Kotlin in Debian, so we like help. JVM languages, of course it's not all about Java. A lot of other languages run the Java virtual machine. We provide Groovy 2.14, Scala 2.11. 2.12 requires SBT, that's Scala build tool. And we have some problems here too, so help is wanted. We will ship Closure 1.9, Jython 1.71, JRuby ? It has currently 3 release critical bugs, so I don't know if we can ship it in Buster. IDEs, unfortunately Eclipse is gone because we have no maintainers who want to maintain it. We once had 5 once, today there's no one. I have packaged NetBeans 10 for Debian a few weeks ago, which was a very demanding task, but it will make it into Buster. Very important for server users, and we will ship with Jetty 9.4 and Tomcat 9, fully up to date and with systemd integration. And last but not least, reproducibility levels are at 85%. What does it mean? So if we want in the future reach 100%, that means you can verify if a binary package built in Debian corresponds to the sources. So that gives you more confidence in what we ship, and it gives you another security level or a new layer of security. You can learn more about the reproducible builds effort at reproduciblebuilds.org. This is a whole another talk, very interesting topic. So now I want to talk about some challenges that we face in our daily packaging work. You know that many build systems just download binary packages from the internet. This is the intended use case. So in Debian, we say that our software requires, if the software requires other software from outside the main archive, that's not allowed. So we make sure, we promise you that everything in Debian is built from source and complies with the Debian Free Software Guidelines. And we cannot promise that if we can't control the binaries in external repos. That's not possible. So every time someone ships only the binaries, for example, in end projects, where you often can see that a developer includes jar files, then we have to remove them because we cannot control what's in them, and we don't have the sources. So how can we verify that this binary package is actually corresponds to a specific source package? So there's security risks involved, there are software freedoms involved. So we say no downloads at build time, only build with packages that we have the source code and that we build ourselves, that we can control, and that will not vanish sometime in the future when some repo, an external repo, will go offline or something else. Then the major point is Java is version-centric. That means you have your POM file and you declare several dependencies. So one project declares a dependency on a library 1.0. Then another project declares a dependency on the same library, but version 2.0. And third one on 3.0, and so on. So for the casual Java developer, that's not a problem, but that doesn't scale very well if you try to package that for a distribution like Debian. So we would have to package every version and include it with Debian. And that's time-consuming, a waste of disk space. There's security risk involved. What do you do if some security vulnerability is discovered? So you have to check, is version 1 affected, is version 2 affected, is version 3 affected, and then you have to update all these packages. This can work if you have a dedicated staff who works full-time, paid on your software projects and does nothing else than updating these projects. But it is very difficult for a volunteer project like Debian, where you have unpaid contributors who have not that time. So a big problem is also that many projects ship Uber jars or fat jars or bundle everything into one big piece of software. I've seen even recommendations for shipping OpenJDK alongside with your application. So this opens enormous security holes. It is very difficult to ensure that you can maintain this project. There can be a lot of security vulnerabilities. How can you verify that this will work in 5 years? So you have to constantly update the whole package and make sure that it works. And that's a very demanding task. So in Debian we say we ship only one version of that package. And we make sure that this one version works with every other package in Debian. And that you can independently update. This simplifies security support and reduces code duplication. But this use case is not very well supported upstream. So we constantly fight with build systems that assume that it's okay to download various different versions of some library, and we have to patch them. And that makes life very difficult. This graph shows a little bit what we face, the amount of bugs that we fixed in the past years. You can see there's a slight increase, and obviously in 2018 something happened. And you can also see that only a few contributors fixed a lot of bugs. I don't want to belittle those contributors that fix only a few bugs a year, because we have more than a dozen different contributors, but they concentrate on one package, and sometimes these packages are not affected by many bugs. So it is unfair to say they don't contribute anything meaningful. I would never say that. Or we have other contributors who just update documentation. So this is also very important, but they won't show up here. But what I want to tell you with this graph is that we lack more people who want to, who want to get the bigger picture right. So we want to fix build systems, we want to fix bugs in libraries which they actually don't care for, but which are important for other packages. So yeah, it's a bit, it's not equally distributed. As you can see, the yellow guy fixes almost 3 times more bugs than the next guy. And if he gets a cold or moves on and does something else, yeah, we have lost a very important contributor, and the project will suffer as a whole. But that's obviously not good. Back to 2018. In 2018, the OpenJDK transitions happened, 9, 10, and 11. And this caused a massive increase in bugs, for example, in build failures, most in build failures, because classes were removed and methods were removed. The OpenJDK maintainers will say, okay, that was suspected. We have deprecated all those classes years ago. Why didn't you fix it? The problem is many upstream projects say, well, it works with OpenJDK 8. Why should I update? But we have to make sure that we can ship OpenJDK 11 in our next stable release, because that gets 5 years of security support. So if we ship OpenJDK 8, it will work now, but not in 5 years. So if you depend on security support on the server side, then you have to choose a long-term supported OpenJDK. So it is not true that Debian ships only old and outdated software. Actually, we work on the forefront, but the actual development happens in Debian Unstable. And if you download Debian Unstable, you could see all this, what's going on with the transitions. And there's a lot of work involved to make every package buildable with OpenJDK 11 and also work at runtime with OpenJDK 11. I think that's a bit unappreciated by some people, but it's a very important task for Debian. Yeah, that concludes my talk. Do you have any questions?
Thank you very much. Anyone with a burning question? I will run to you with the microphone. Okay. So, do you hear me? Okay. What do you do when you face a situation? So a piece of software is not compatible with OpenJDK 11. Mm-hmm. So how do you decide? So does your team act then and does something on the code, or do you reach out to the software project, or are both approaches valid, and how do you decide which approach to take?
Yes. Thank you for the question. So there are usually 3 paths involved. First of all, we contact the upstream project and look for new upstream versions, obviously. So we always try to have the latest software in Debian. So naturally, that's the least amount of work for us. So and if we discover upstream is not ready yet, so we have the choice either to patch the actual version, to work around the problem somehow, or to actually fix it. If we can fix it, because it's a simple fix, or we just have the capabilities to do so, then we forward the patch upstream. And upstream will hopefully implement it and import it. If both of these ways don't succeed, then we have to remove the software from Debian, because if we cannot build it from source, then it's does not meet our quality standards.
Okay, thank you very much. Can I ask for a warm applause for Markus?
Thank you very much.
Thanks a lot for the talk.